Greetings and hello. My name is Mohammed SAUFI, and today my group are going to present our case study about the Bhopal gas tragedy, or mostly known as the world's worst industrial disaster in human history. To provide context, on the night of the 2nd and 3rd of December 1984, catastrophe struck in the city of Bhopal when a massive volume of highly toxic MIC gas escaped from the UCIL pesticide plant. This incident resulted in a massive loss of life in which a total of 20,000 total deaths were recorded and left the city's local environment to be poisoned even decades after the tragedy. The incident began when a worker was cleaning the pipes in the facility, but due to negligence from the company, isolation blinds were missing, allowing water to leak into tank E6010 containing the highly toxic MIC gas. This then led pressure in tank E6010 beginning to rise, in which then operators dismissed as an instrument error. MIC fumes were then reported near the production area as pressure gauges goes off the scale. The final piece before tragedy struck began when when the slab of concrete above the tank cracks, in which then the safety valve pops open, releasing gas into the atmosphere. Afterwards, shrieks of terror began wailing down the streets when the toxic cloud drifts over the sleeping city of Bhopal. This tragedy could have been easily avoided if the weaknesses in safety management weren't ignored. The first sign was inadequate maintenance and equipment failure. Critical safety devices designed to neutralize the gas were non-functional or turned off to save money. Then, poor operational procedures and training. The workforce in UCIL were severely reduced, undertrained, and fatigued. The next sign was the flawed plant siting and emergency planning. Lack of communication with the public and poor planning led to multiple locals losing their lives. And finally, corporate governance and double standards. The Bhopal plant relied on manual safety systems, whereas the sister plant in West Virginia, USA, had computerized automated warnings. The ones responsible for allowing such actions to take place and the ones who are to be held accountable are none other than the CEO of the Union Carbide Corporations himself, Warren Anderson, head of the parent corporation at the time. He was charged with culpable homicide but successfully evaded extradition from the US to stand trial in India. Next are the companies themselves. Union Carbide Corporations and Union Carbide India Limited were responsible for the negligence and dangerous cost-cutting measures which ultimately led to causing the tragedy to happen in the first place.
Assalamualaikum warahmatullahi wabarakatuh. My name is HABIBURRAHMAN and good morning. Today I will talk about failure mode and effect analysis or FMEA. In Bhopal disaster, we got five main function active process before the accident. Number one, we got chemical storage. The chemical storage of methyl isonate (MIC) in large underground tank. Number two, maintenance and cleaning active, flushing, repair, isolation, and inspection of equipment. Number three, emergency response and alarm system, gas detect, emergency siren, communication, and evacuation response. Number four, chemical handling and transfer, transfer of MIC between tank and process line. Finally, safety and control system, operating of scrubbing, refrigerating system, flare tower, and pressure monitoring. For the table FMEA failure mode effect analysis, I will tell the highest RPN only for this table. Okay, so first process step, MIC storage. Potential failure mode, water ingress into MIC tank for the potential failure effect, violence, extremate reaction, SEV10, potential cause, faulty valve, OCC6, current control, poor isolation produce, DET9, and the RPN is 540. Correct action for this MIC storage, install check non-return valve. So and double block and bleed and automatic isolation interlock. Number three, handling transfer. Pipe leak, corrosion during transfer, slow leak, SVE9, potential cause, raw material selection, OCC7, current control, visual inspection, DET9, DET6, and RPN we got 378 for the corrective action, schedule NDT and corrosion monitoring, and finally maintenance and cleaning. Improve improve improper flushing and water backflow into MIC line, potential failure effect, water trigger reaction in MIC tank, SVE 9, potential cause, weak supervisor during cleaning, OCC 5, uh, current control, loose permit to work practice, DET 7, and RPN 350, corrective action, enforce strict permit to work and formal LOTO, supervisor sign off before flushing. After we see the table FMEA, we got top 3 critical failure and corrective action for Bhopal disaster. Number 1, MIC storage, water integrates into MIC tank. So they need to install, check, non-return valve, double block and bleed, moisture or water sensor, automatic isolation interlock, enforced permit to work, and also secondary containment and neutralization pit. Number 2, handling and transfer. Pipe leak, so they need to schedule the NDT and corrosion monitoring so they can replace critical section with corrosion resistant material. Lastly, number 3, maintenance and cleaning. Proper flushing and water backflow into MIC line. They need to enforce strict permit to work and formal LOTO. So the supervisor need to sign off before flushing the MIC line using inert pure method instead of water. They need to have a training, competency and checks. That's all for me. Thank you.
Assalamualaikum and good day. My name is FAIQ Nabil Ashraf and I will be presenting the MSDS analysis section, which is stand for Material Safety Data Sheets. Without further delay, the chemical involved in the Bhopal incident is methylisunate, in short form MIC, which is used primarily as an intermediate as pesticide manufacturing. The chemical has several hazards, which is highly flammable, extremely toxic, corrosive, and highly reactive. As shown by the GHS pictogram, it includes signage for flame, skull and crossbone, corrosion, and lastly, health hazard. Next, here is the official MSDS that I obtained from my research. I've also provided a PDF link at the bottom for further reference. This is also the official MSDS, where the PDF link is at the bottom. Back to the MSDS analysis. For the exposure limit, MIC has a very low allowable concentration in the air, which is 0.02 ppm. This means even a very small amount can be dangerous to health. For the PPE required when handling MIC, workers must wear respiratory protection, chemical-resistant gloves, and safety goggles, and contaminated clothes must be removed immediately. Next, for the health hazard, this chemical can cause skin irritation, breathing difficulty, allergic reaction, dizziness, and may also cause damage to organ through long-term exposure. It is also suspected for harming fertility and unborn child. For spill and fire control, it is important to keep away from ignition sources because the chemical is highly flammable. Spill must be absorbed with sand or similar material and keep away from drain or waterway. Fire should be controlled using CO2, dry powder, or water sprayed. In addition, the first aid measure for MIC include moving the person to fresh air if inhaled, washing the skin with water and soap, rinsing eye with clean water, and not include vomiting if swallowed. Medical attention must be given immediately. Lastly, I would like to talk about the hazard comparison and the highest risk chemical. Based on MSDS analysis, MIC is identified as the highest risk chemical because it is extremely toxic even at a very low exposure limit, which is 0.02 ppm, highly flammable, and can easily form harmful vapor. It is also cause serious breathing problem, skin irritation, and long-term organ damage, and is suspected to harm fertility and the unborn child. Overall, the combination of highly toxic, fast vapor release, and multiple health danger mean methylcyanide possess the biggest risk of human health.
Hi, I'm Hakim and I'll presenting safety improvement and prevention plan for our case study. Based on our FMEA and MSDS findings, we propose 5 improvement plan. The first one are by improving the MIC storage safety by limiting tank fill to no more than 50% capacity and a daily inspection checklist and weekly leak tests. The second plan are a safer chemical handling and transfer. For examples, by monitoring real-time flow and pressure with automatic shutdowns and a permit to work for the MIC transfer work. The third plan are maintenance and cleaning controls. For examples, by installing a gas detectors around maintenance zones and having a competency test for workers before doing a maintenance work. The fourth plan are by strengthening the safety and control system operations. For examples, by having the MIC alarms detection to be turned on all the time. And the second is by planning a scheduled preventive maintenance programs in case any accidents occurred. The last one are the emergency response and alarm preparedness, such as making sure the siren system across the citywide to be fully functional, creating the community emergency response plan, and having a public drills exercise for every 6 months.